Welcome to episode 321 of CppCast, the first podcast for C++ developers by C++ developers. I'm your host, Rob Irving, joined by my co-host, Jason Turner. Jason, how you doing today?
All right, Rob, how are you doing?
Doing all right. You got anything you feel like opening up the show with today?
Well, I don't know. I was just thinking when this airs, it'll be really close to CppCon, won't it?
It will be. It will be. And really close to, hopefully, your Norway trip.
Yes, I will be theoretically getting on an airplane or something.
Theoretically. Hopefully that is able to happen. Yeah.
No way to know at the moment.
Okay, well, at the top of every episode, I like to read a piece of feedback. I got this DM from Paul Leslie. Paul says that he's from the Auckland, New Zealand C++ user group, and they've been on a very long hiatus because of the pandemic, but they're going to do a virtual meetup this coming Wednesday, October 20th, and was hoping that we could give a shout out to all of those Kiwis in the C++ community. So yeah, if you're in the Auckland area and want to rejoin the C++ group, it's reopening very soon. Check it out.
That's exciting.
Yeah. I guess anyone could join if it's virtual, but time zones and everything.
Yeah, time zones are hard with New Zealand, but yeah, it's possible.
Yeah.
I have not yet missed a meeting, but it looks entirely possible that I'll end up missing one in November. I mean, like my meetup won't have one in November because my co-host is co-leader is currently unavailable. And I'm going to be, I think, unavailable with everything going on. But
that's pretty impressive that you kept it going this whole time during the pandemic, though.
Well, and we've never missed a month, ever, since starting the meetup 4 years ago or whatever.
Yeah, that's very good.
Yeah.
All right. Well, we'd love to hear your thoughts about the show. You can always reach out to us on Facebook, Twitter, or email us at feedback@cppcast.com. And don't forget to leave us reviews on iTunes or subscribe on YouTube. Joining us today is Joël Falcou. Joel is an associate professor at the University Paris-Saclay in Orsay, France. His research focuses on studying generative programming idioms and techniques to design tools for parallel software development. The main parts of his work are the exploration of embedded domain-specific languages designed for parallel computing on various architectures, and the definition of a formal framework for reasoning about metaprograms. Joel is the co-host of the C++ French meetup, president of the C++ French Association, co-organizes the CPPP conference, and is part entrepreneur, being one of the founder of Code Reckons, a company focused on bringing people and companies up to date to the best and newest C++. Joel, welcome back to the show.
Thanks again for having me, Jason, Rob. Always a pleasure.
So, while I've got your unique attention at the moment, do you want to give us a quick update on Ppp Pvp, CppPP?
So we closed the call for paper last week, September 30th, and we are currently reviewing the
paper
proposals right now, and we aim to have probably some results, some programs soon. We will probably start, advertising for the conference. We have our keynotes and stuff like that to speak about. So it should be on track for December. It will be fully online. And we will try to, accommodate our North American audience by placing talks on a proper time zone for everybody. So that's also something we want to do. And so that will be our first, second edition, first online edition. And we will be trying to see if we can actually get a third edition next year, but I hope in person this time. I think it will be long overdue for a lot of reasons. And you were speaking about the virtual meetup for the New Zealand people. So we have been resuming the C++ Frog meetup since almost a year now. We do that on Discord. We have a Discord server. If you want to join in and follow the meetups there, if you ever happens to want to see French people with bad English accent speaking about things, or the other way around. And you're also very welcome if you want to give a talk or something, because we like having people from elsewhere, because it's rather rather easy now that we do that online. We had actually had a lot more participants. One problem with the meetup was that when it's in person, you are in Paris, and France. France is basically the size of Texas,
Right.
but Americans have this a bit of driving long distance, doing things, getting from places to places, and it's not something that French people do a lot, especially above like the 100 or 200 kilometers range. So it was very it was a very Parisian in Paris meetup, and now that we are on Discord, we have a lot of people from all over France, and so that's kind of cool. That was the unseen benefit of the situation.
Right.
So, but if you are, if you are like, I don't know, French Canadian and you want to participate, you are very welcome. Or even if you are not necessarily a French speaker, we can accommodate that. So be our guest and come over.
And the entire thing is hosted on Discord?
On Discord, yes. And we have a special setup so we can actually manage the let's say the Discord's limitation on how many people can actually have a look at stuff and so on. So it's actually okay. It's actually okay, and it's also a trial for the CppP that will be also hosted mostly on Discord. So
interesting. That is actually really interesting. Oh, and you said you're going to try to accommodate North American time zones a little bit with Ppp.
Yeah. I forgot the P, I guess, but yes.
I think I forgot the P. I did just notice, and I think it's worth commenting for the sake of our listeners, that CppCon is also attempting to accommodate Europe a little bit.
Yep.
The really late, or what would be really late in Europe talks are going to be replayed the next morning with the speaker live to answer questions.
Yeah,
that's a great idea.
That's a very good idea.
Yeah,
that's a very good idea. And you have the other side of the coin. I was joking about on my Twitter status a bit long ago when I actually got my time slot for CppCon. It was like at 7:45 in the morning, and I was like, ooh. So it's fine for me because it's the middle of the afternoon. But I was like, oh god. Because 7 p.m. you really want to be, dealing with these kind of things.
Yeah.
So we'll see how it goes, but it's actually very good to be able to interact with people again. That's the one thing I missed a lot from all these times.
Okay. Also joining us today is Denis Yaroshevskiy. Denis is a semi-active member of the C++ community. He's mostly interested in algorithms and has done a few things in that area, such as research and implementation of Chromium's flat set, a couple of tiny contributions to libc++ algorithm library, a few algorithm-related talks, and one sole paper to the C++ standard that didn't get consensus. For the last couple of years, in his free time, Denis is implementing STL algorithms portably using SIMD. Denis, welcome to the show.
Hi, nice to be here.
What's the paper you submitted that they didn't get consensus on?
Well, the paper was against accepting flat map in the shape that it was at the time. It didn't get consensus, but as you can see, we don't have a flat map, so I guess I won.
Yeah. Oh my goodness, I've re-implemented a simple flat map probably 10 times at this point. It's such a handy thing to have in the simple case.
Well, they wanted to do parallel arrays, and my paper was against doing that, especially until we get zip. So right now, the zip proposal, I think, has come through, so C++ 23.
Yeah.
But I said, so the main point was that if you know zip, it has a problem with proxy references. And the paper was basically arguing that if we're going to do proxy references in the C++ with all of the downsides that it brings, and we should do it with open eyes and do the zip first, and then maybe do a flat map as parallel arrays after that. But also, I measured, and it's not actually a win for a flat map to do parallel arrays. So kind of like the paper was about that.
Okay.
Well, Joel and Denis, we got a couple news articles to discuss. Feel free to comment on any of these, and I'll start talking about Eve and SIMD, okay?
Sure. All
right, so this first one we have is Qt 6.2 has been released, and this is the first LTS release for 6.0, which is long-term support. So, Qt 6, I guess, was a really large change. I think we covered when that first came out a while ago. They're now using C++17. They're using CMake. And with this release, though, they brought back a bunch of modules that were not available in Qt 6.0 or Qt 6.1. So now, if you're using any of those in previous versions of Qt, you should be able to use 6.2. Are either of you Qt users?
Not much for myself. I don't know, Denis. Are you doing Qt things?
No, I'm not
I don't
doing-
think so. Yeah.
I'm not doing Qt, but like I looked through the release notes and there is so much. Like it's kind of it's even more than Boost stuff when you have like C++ libraries that are not just a library or a framework to do things, but maybe because we don't have package management or some other reasons, like we have this gigantic monsters of a thing that brings like everything together.
Yeah.
Yeah.
I was just.
But it's I miss the point where they switch to a proper C++ standard. So that's things that's very, very important for. I mean, we maybe some of you remember the what was it, like 3 years ago or 4 years ago when we had the Qt guy at CppCon?
Oh, yeah.
Was a bunch of time ago, and you
One of
could
the
see there was
keynotes.
some, I guess, and you could actually feel the it was some kind of not tension, but you see like some disconnection between the way he was actually presenting Qt and how it works, and the way some people from the audience was actually looking at it. So I think it's a great move. They move that much. The CMake thing is also a great change because I still have nightmare of QMake when I had to do some ages ago. So no, that's cool. It's actually moving in a good direction. So I mean, I think that I don't have any opinion about the fact that it's is it the best GUI library or not? But I know it does the job. It's consistent. It's it exists and it does the works. And I guess that for such a thing, it's probably the main the main features you want. You want something that just works, and the fact that they have this ongoing changes, it's actually quite good for the library and the let's say the Qt ecosystem itself, which is, as Denis says, it's like a massive brick of things. No, that's good news that they went forward like this. So yeah, maybe I should try to do that at some point. Probably probably brush up my dynamic C++ a bit. So.
I have a friend. Sorry, go ahead, Dennis.
I just want to say is that in any project that I saw in C++, there is this whole ecosystem built. But in my case, it was mostly like really big companies that have their own ecosystem. But if you don't have one, like maybe Qt is a good shout, right? I need networking and UIs and all of that stuff. And
you get it on one, yeah.
Yeah.
I have one friend who is not a C++ programmer, and I told him that there were a bunch of people asking for me to do Qt tutorials on my YouTube channel, and I'm like, it's been like 3 years since I've touched Qt. And he's like, well, that's a GUI library, right? And I'm like,
it is.
Sure.
It is a GUI library.
It is a GUI library.
It's
also a networking library.
Yeah.
And yeah.
Was it what's the name of the other? Oh, but it doesn't do GUI. Falco is also a huge mass of let's say let's call that productivity tools. Like I know they have networking and stuff, but they don't do GUI.
It's like everything except that. Yeah.
So okay. The one thing I always found funny is that you end up in those huge company or places where they will happily gobble up the dependencies to Qt or Falco or sometimes both. I don't want to know why. But then you suggest them to, you should use these Boost things, and they're like, oh no, you don't think about the dependencies. And I'm like, guys, I mean, you already have like I don't know, like I mean Qt is basically the Node.js of C++. You know, like it's you think it's okay, and in fact it just like comes with so many things. It's not even funny at the end. So I was always like pondering about why the Falco is fine, Qt is fine, Bose is fine. Boost, no, I don't want to do that. It's too much dependencies. I never really understood this position, but I mean, maybe there is a reason or something. But
I've definitely worked on projects where, Qt, when we had both Qt and Boost in the project, it was a lot to manage. One or the other is fine, but both, and then having things like Boost ASIO expecting some version of OpenSSL that Qt's expecting a different version of OpenSSL, and then the whole world just goes to crap.
Yeah.
That's where the problems happen.
Yeah,
I think we had 4 different versions of libz linked into that project at one point.
Oof.
It just happens. Once you add 4 large dependencies, that's just where you are.
All right. Next thing we have is this project on GitHub. It's Gdb Front End. And I'm not a Gdb user. So Jason, I might need you to talk more about this one, but it looks like it's pretty powerful for giving you a GUI on top of Gdb.
Yeah, this is the author of this contacted me and said, hey, you might be interested in this. And I have not yet played with it, but it looks pretty powerful if you're not already using CLion or MSVC or something else with a nice debugger front end. I know, Joel, you do everything at compile time, so you don't have any use for a debugger.
Well, I took a look. It looks very nice, actually. From the like the screenshots and the demo things.
Yeah,
it looks quite impressive. And I don't maybe use that much, but I know that I always have this trouble. Gdb is something which is very complicated to teach to people, because it's let's say that it's off-putting because it looks so antiquated when you just fire it up when you have people that are used to get IDEs and you click on a button and stuff. So sometimes it's very complicated to get people inside it. And but once they are inside and you teach them actually the ropes, it's okay. So maybe it's actually something that could actually get more people to jump on Gdb. And I think the less people actually debug with printf, the best it is. If you see what I mean.
Right.
And I know that some people are just frightened by the raw Gdb things, so it can actually help people jump onto this wagon. So I probably give it a try because it really looks like very nice, polished, and well thought out on the way it interacts with the Gdb basic functionality. So it's definitely something to have a look at, I guess.
But you, Dennis, are you a Gdb user?
When I have to, like I basically, when I see there was talks by people from Gdb, right? And they're like, well, we can do all of these amazing things. And like, if I manage to put a watch point on a variable, I'm really proud of myself. like realistically speaking, I can open a core dump and look at that. And that's the extent of my master Gdb skills. I should know more, but there is no way I can do UIs. It's all on the server somewhere. So like, if I could do SSH setup, I would be much better at setting up things than I am.
Yeah, it's one of those guys from Undo or something who has given a bunch of talks at CppCon on Gdb, which I think might be the ones you're referring to, Dennis, which it's practically like watching a magic show when he's like, and now what we can do with Gdb with the Python plugin. And you're like, what just happened? Like,
I thought the one I was referring to was by a Gdb maintainer. But maybe. I might be wrong about that. I'm not sure. There was a short one and then an hour-long one.
Right.
Okay, and then the last thing we have is on Reddit, linking to a post from Nikolai Josutis we had on, I think, a year ago. And he is pointing out that this paper he submitted to fix the range-based for loop in C++23 was not accepted. And the C++ committee doesn't want to fix it apparently it's been broken for 10 years. I didn't realize there was a problem with the range-based for loop until reading this. It's not something I've
we
run into.
discussed it very briefly when we had him on the show.
Okay.
Just very briefly, I think.
I wrote that bug the other day. Right? So like that specific bug, I wrote it. So like for people who didn't see, so it's talking about like we didn't mention what the bug is. So basically you have a temporary object and you try to iterate over. So if you just try to iterate over temporary object, it works. But if you try to iterate on something you get from a temporary object, it doesn't work because the temporary object goes away. Right? If you have a function that returns, something with a map member, and you try to get that member, like that will not work. Yeah, I wrote that bug, and somebody mentioned V lifetime extensions, that it should catch it. Would be really nice. So,
Yeah, that seems to be the committee's consensus here, is that they want a general lifetime solution, which Joel seems to be thrilled about.
It's not that they want that. I mean, lifetime extension standardization is a good thing, but I have like flashbacks on that one guy or that couple of people that came with a very simplistic way to get, you can print the name of an enumerator or something, very smooth things, and then so was, okay, what about having full-blown reflection? So we are again in this situation where we could have very, limited chirurgical strike on a problem and it get fixed. And somehow we decided to go for the complete, a world-saving scenario instead of locally fixing the things. That's what I'm more, rolling my eyes over than the actual issue. The issue is an issue. I have been fall into this trap I don't know many times, and each time it's time for a huge site, and so I don't even understand why he didn't pick, because the fix that was proposed in the paper, if I remember, was rather simple, because it just changed the the equivalent syntax of what the for auto loop expands to,
right?
And it should have been a no-brainer in my opinion. So deal with it, and especially because I mean it's not something like it happened for, I don't remember what recently. It's not like it's something we just came upon right now, say, oh crap, we forgot about that, it's late, we have to think about it properly, so let's delay. It's a 10-year bug.
Yeah,
right. It's a 10-year bug. So I mean, well, whatever.
Interestingly, I don't think I've ever personally seen this in the real world.
It happens. It happens, and sometimes you do it. I mean, what happens a lot to me is that you do it, like you forgot about that, and works on your machine, and you ship the code, doesn't work on the other machine, and you're like, what the heck? And then, oh god, yeah, the map from the temporary, or the vector or whatever, and then you're screwed. So the local fix for people is not very complicated, but it's just but ugly to have this. You put the variable before and then you do your whatnot. It's probably sometimes not efficient because you have to probably make, well, if everything goes well, maybe you're just being a move, but worst case scenario, you probably have a copy or something if you don't end up doing it properly, or you are in a situation it can be moved or whatever. So my opinion is that it should have been fixed with the chirurgical strike, and then later, let's have a decade-long discussion about general lifetime management, and see what we can do for C++33 or something. But well, yeah, sorry for being so jaded about the process, which I am actually part of, so I have no excuses on that. But well, that's 2 or 3, occurrence of things that just you just sided at that, and okay, well, whatever. So that's the, how to say that, that's the downside of working designed by a committee consensus. That's the, I mean, that's the rule of the game. So well, whatever.
All right. Well, let's start talking about Eve, which I don't think we've discussed before on the show.
No.
But could one of you give us a little intro to that library?
Well,
You start.
yeah.
You start, and then I'll talk how I came to Eve.
Yeah, let's do that. So, a long time ago, once upon a time, I was actually, Eve is like, let me count, 2021. It's basically the end result of, let's say, 13 years
Wow.
of, playing around that. Eve is actually the name of my first CppCast wrapper utility tools that I wrote during my PhD thesis. And that lay dormant for a while, that get merged into the linear algebra / numerical array library that I wrote at some point, that tried to get out as Boost.SIMD for a while. And then that went dormant again for a lot of reasons. And I went back to the problem in 2018, something like that. Well, yes, 18. Yeah, it is. Because the problem still wasn't solved. I mean, you have this huge amount of processing power in regular CPU. Let's put the GPU outside. And you have a lot of things. You have the multi-core parts. You have all the internals, and you have those special multimedia instruction sets that are there since 1995, 6, something like that are supposed to help you write efficient code when it fits the model of SIMD, which means that your data are well laid out, contiguous, and you do the same operation on everything, which is basically what happens when you're dealing with, I don't know, like image processing, signal processing, scientific computing, whatever. That's the obvious things, and you have the non-obvious things, because well, if you have a very, very long string, it's basically an array of characters, so it's just an array somehow. So maybe you can actually, make your string processing faster or whatnot. And it was always seen by developers as something which is very obscure. Because the API is a nightmare, both in the naming scheme and the way it works, and the fact that it relies on half macro, half intrinsics. You never know which one is what or whatever. And the other problem is that you probably have like 12 or almost 12 or 10 or 12 variant just for x86. And God forbid you need to write code that use those things, and you have to go on like multiple kind of architectures, like, I don't know, like x86 and ARM, if we stay on mainstream architectures. And nobody wanted actually to write that. Compilers, which are supposed to help, tries. You get auto-vectorization in most compilers since ages also. But as soon as it's not what the auto-vectorizer is trained to recognize, to analyze, well, you don't get it. So it was an issue in 2005 when I started my PhD. It was still an issue when I went back to the problem 15 years afterwards, 10 years afterwards, something like that. And I wasn't sure it was something we needed to do again, because I was under the impression that the current compilers went far better than they should be now, and it's probably something we don't need, except for very specific cases. And in this case, you know what, I will just write it by hand. And after getting involved in a couple of projects that were quite performance critical, and actually witnessing it was clearly not a solved problem, I went back at the drawing board. So the main idea was to say that whenever you compute on a regular types, like you do computation on an array of float or doubles, you have a bunch of operators, you have a bunch of functions that work on those types, and they do one computation. And one thing that we actually spoke about and worked on was to have like a type wrapper that says this is not a float, this is a bunch of float. and the size of the bunch depends on your architectures. You don't have to care about it. And whenever you operate on this bunch of values, the library will take care of actually figuring out the best, intrinsic to call, the best combination of intrinsic to generate, and so on. So you still write code that looks like, let's say, normal, scalar code. Just thing you did is change the variable types. And if you are doing a loop, you do the loop in a slightly different way. And by actually using a bunch of metaprogramming tricks and some other template-related shenanigans, you could actually hide a lot of things, including the fact that you can detect which is actually the proper architectures you need to target, and then you can decide what you want to do with your bunch size, and so on and so forth. And so we started working on that back again, 2018, and I was using it as a way to say, okay, now you know that C++17 is quite well supported, like on multiple compilers. Let's write it in C++17 so I can actually, get up to the new features and so on and so forth. And I was majorly having a good eyes on ifconstexpr, which was looking like a perfect, dream operation for what we wanted to do. And so we started writing a C++ version of that, which was a mismatch of what Boost.SIMD was in terms of design and what the old Eve was. And then we started, playing around with C++17. One thing I quickly learned that was you cannot just take a design from ages ago, change the standard number, and sparkle some stuff. You need to actually rethink the design with the new features in mind. And I learned that the hard way. So we started actually writing, okay, can I do that actually? What if I do this ifconstexpr trick in this lambda thing and so on and so forth? And we started to get new, better design. And at some point, I don't remember exactly when, it's probably late 2019, we started having a partial support for C++20 in GCC when it was back, STD C++2A, something like that. And I was like, oh yeah, you know what? We should make a branch and try to see if the new C++20 concept things and so on actually help us. So whenever it's, actually supported, we already have, a base to work with. And 6 weeks later, the conclusion was, okay, you know what? Let's stop C++17 and jump onto C++20 right now because it's so much easier. And we basically divided the code size by 2.
Wow.
Something like that. Wow. By moving a lot of, complicated, let's do a constexpr function that evaluates the thing so I can put it back into a thread that tell me if I can call this or that into, let's just make a concept and put it into the template stuff and thanks for playing, And it was easier to, to express what we wanted to do this way. And I know Denis will laugh when I say that. And the compile time was so much better. It was so much better than before, let's say it this way. And so we decided to just say, okay, anyway, currently it's not something that is completed anyway. We have this, we have these chains where when you do research that you can actually say, what, I will just scrap that, start again, and use these bleeding edge things, and we will see later who want to use that anyway. So we took this opportunity to rewrite again a lot of stuff. As I say, we probably dumped half the code we wrote, and basically what left was the actual, math things that compute the function, and everything else was completely, stripped down and rebuilt better. And that was basically when you come in, Denis, I guess, around 2020, something like that, end of 2019. I don't remember.
Yeah, something
like that. Yeah. And so Denis just pinged me on Slack, and you said, I don't remember what it was for actually at the beginning.
I was doing a talk.
Oh yeah.
Yeah. So
yeah, go ahead.
Okay, so yeah, I was basically Right. So if you look at anything online that talks about SIMD, right, they will say if our data is perfectly aligned and divisible by our register size, and the stars align and all of that stuff, then you can do you can add two vectors together and get a third vector. And in the meantime, I know that strlen exists that is completely vectorized. I know and doesn't require your strings doesn't have to be aligned to anything. Right, there is student6 that says, "Hey, we should have a vectorized sort." Right, we should have vectorized all of those things, and I wanted to know how it's done. Right, so I decided that I bugged a bunch of people. I bugged Bryce, who said, "Go to GPU."
What do you want to say anyway?
I bugged Gasper, I bugged a bunch of people, but the answer was on Stack Overflow, and there is an amazing community on Stack Overflow. Shout out to Peter Cartes, most of all. Anybody who asks anything about x86 on Stack Overflow will find his answer. Right, there are some other amazing people. There is a Tehiago, I don't know his last name, on Slack, who was also massive help. And basically, Akrit, Zibazan, I'm just trying to remember people who were really helpful, sorry. Yeah, and I learned all of those things, and I gave a talk. That was my goal. And in the middle, so I went online to look for a SIMD library. I saw a talk by Jefferson Asmus, I think, I'm sorry for butchering your last name, who talked about SIMD wrappers libraries, right? But basically what Joel talked about. So you have a class that says, this is my register of integers, let's say. And I was looking for a library like that to do my talk, where I want to write strlen, I want to write, sort maybe, but the algorithms I did was strlen, reduce, inclusive scan, and remove, right? That was the algorithms of my talk. And then, and so basically, he talked about these libraries. I looked at a few of them. I looked at VC, which is probably the most popular one at the moment. It's a basic for STD-SIMD. I looked at TSIMD, XSIMD, and they scared me. They look just very complicated. And if you open the examples, it's like all of that metaprogramming. And, for example, VC is probably the most mature of all of them. But they try to do a lot of things for you, and you kind of lose. I think that, probably you have the same experience with Eve, to be honest. Like if you open Eve and you try to dig through it, it's probably also scary. Anyways, and then I stumbled about Joel just on Slack, and I asked him, "Hey, you were doing this thing with SIMD. Like if this is what you're doing, like I'm giving the talks that builds on top. Do you want me to build my talk on top of your library?" Right, because it's kind of a cool use case. Like, can you use a library to build a find, right? And this is how we started to kind of doing things together. So right now, I gave my talk, and then we ported now all of my algorithms between all of x86 and ARM. So for example, we now can take remove and vectorize it on any x86 and ARM, and on my machine, for example, for chars. If you want to remove space, let's say zeros. If you want to remove zeros from an array of chars, we can do it up to 25 times faster, right, on a single core. For 1,000 bytes, it doesn't have to be a lot. Yeah, and so we ported all of that. We also support things like the last effectively cool thing we did was support of parallel ranges. So for example, right now you can do inclusive scan of complex numbers, right? So you have one vector with real part, one vector with imaginary part, and you apply inclusive scan on all of that. So yeah, and that's kind of my story with it. So now I'm active contributor and doing awesome stuff.
But when you said standard algorithms, but is it algorithms that look like standard algorithms, or does it somehow actually work with the actual your standard library standard algorithms?
So okay, you can pass it a standard vector that works, but it's our algorithm, right? Okay. So there is an implementation of inclusive scan is our implementation of inclusive scan, and even the interface looks slightly different to the standard one. So specifically, for example, for inclusive scan, you need to know what 0 for your plus is. All right, so you have a plus operation. And a plus operation needs to know its identity element. right? There's a thing you add with anything, and you get the same value. Does that make sense?
And it's
Sure.
different, and it's different from the base value you want to inclusive scan over. So sometimes people usually mix them up, but it's you need your base value, and your operator must be paired with an identity element. And currently, the best thing we found out is that you actually pass a pair of the identity element and the actual function, and it just works.
Okay.
I don't know if that's super confusing and a lot of information.
No, that's fine. I'm just trying to like, I'm thinking like a little bit more the use case. Like, okay, you're trying to sell this library to me right now, theoretically.
Okay.
Can I throw like a vector of strings at it, and it's just going to say, you know what, I can't do anything with strings that's special, so I'm just going to pass that, you know, whatever. I'm not going to try to vectorize it. But if I pass it a vector of ints to one of your algorithms, then it'll be like, okay, now I've got your back. It's going to be 300 times faster than it was.
No, it's going to be 8 times faster, but but
For
no.
now.
No, it's a limit. Like on my machine, it's going to be 8 times faster. But no, we will not allow you to pass in a string. We'll just it will say I'm not going to compile, and
Okay.
I'm not sure. But you can do if you have 2 vectors of integers. Yeah, we can do that, right? Or if you have structs. So, for example, one of the things we have an example of is like a data-oriented design system, where you have you know. When we have Joel wrote bouncing balls, that is not terribly correct in terms of semantics, but we wanted to showcase the example. So
They
balls
bounce.
bouncing.
They are not balls, but they bounce. Okay.
Well, they're characters that are like, you know, under gravity, and all of that is vectorized. It's the most useless application of vectorization possible, but it looks like an entity component system.
Interesting.
Yeah, and the one thing we wanted to do, and that was part of the how to say that, the discussion, the reflect, the thought process we tried to have at some point was, okay, everybody and his grandmother have this let me wrap the whatever SIMD type behind the box, and you can play with it. And we wanted to go further than that, because most of the time it just stops there, actually. Right. And as soon as you have something complicated, you have the bits and nuts to do the things, but it's not trivial. So what we wanted to do at some point was to, and for a long time actually, was to actually have the support for, you tell me you have a struct of things, and you want to make this array of struct, and you want to vectorize operation on this struct. Mm-hmm. And most of the time when you have to do that by hand, it's quite cumbersome. You need to, you know, do this structure of 5 things and so on. And we wanted to have something that you can just say, okay, just describe me the structure, and I will deal with it. And whenever you want to vectorize this vector of, let's say, balls or polygons, or I don't know, pixels, we have a protocol you can follow, and we understand it, and then we can vectorize. Because most people doesn't want to deal with having like 10 or 16 arrays that, you know, just go everywhere, because you lose this, this data structure field, okay? And it's easier to think about the structures than just a bunch of values. So we wanted to do that. And the other thing we kind of went to, even if it wasn't planned, when we started doing the algorithms, at some point, it became evident that, okay, we can pass ready-to-use algorithm to people. You have this array of float, and you want to do the sum or the reduce, you can do that. You have this vector of whatever pair of int, and you want to do a find, whatever. But it happens that a lot of time people, they just don't want to do that. It looks like they need a reduce, but at some point they need to do something else, or it's like a find but. And so what we wanted to have at some point was, can we actually write all this algorithm in a way that we can have, basic block that you can use as an advanced user if you really, really want to make that slightly different algorithm. and you don't want to manually deal with all the things we need to deal with the vectorization. We actually had a case like that. What's the name of the guy? Marcus?
Max Marcy, I want to say. I can look
Do
him
you
up.
have it? Which was the main contributor to the RageDB project. That was making a series of blog posts about the fact that he wanted to do some performance thing in the database implementation, and at some point he basically stumbled upon the fact that the next step in his work is basically, well, I need to vectorize that if I need to go faster. And it happens to stumble upon Denis, and Denis basically, you wrote him some kind of POC.
Yeah, I'm sorry, I cannot find.
I will search.
So yeah, basically, so this is one of the examples we're going to show how it's done in the talk we're giving. You have an array, you have a predicate, and you want to collect all the indexes that match the predicate, right?
Mm-hmm.
So just get a vector of indexes, and we can vectorize that, and it's a custom. You need to write a custom loop that will do it. But he claims that he went more than 5 times requests per second in his database.
Oh, wow.
Okay, so you've got all the basic building blocks for building SIMD things in your library, and then you've got what's that?
Not all, but yeah.
Well, I mean, you can build SIMD things, and then you've got higher level building blocks. It sounds like, and then you have a selection of very high level algorithms that you've implemented.
Yes,
is that accurate? Okay, and I can just drop this into my program. Sorry, Joe?
I mean that are the the classical algorithm you are used to if you do C++.
Okay,
we have some of them. I'm working.
Yes.
And somewhere in the 4 to 8 times performance improvement, depending on your architecture and the size of the things that you can vectorize.
Yes. So, well, not, the smaller speed up can be smaller if you hit the perfect case. So probably the worst will be something if you do a remove, which is probably one of the more complicated algorithms we have. And your branch predictor is perfect for a scalar version,
right?
Then it will be about the same.
Okay.
Right. At this point, I don't think I know any case where we're worse than the scalar code, right? And sometimes, we're massively better.
Right.
Right.
Yeah.
That's cool.
And the important thing to understand about that is that it's single core. That means that you are still in core and you have this 2-digit speed up. That means that you are currently saving whatever the extra, speed up of multi-threading should or can bring you to put it on top if really you really need that. And I mean, let's take a very conservative 10x speed up. And now imagine it's conservative. I mean, it's conservative. 1 order of magnitude. Okay, let's say it like that. So you have this 10x thing. Okay, and the idea is to say, okay, now, I will put my. I don't have it there. Okay, I should put my marketing at. But basically, that means that if you are running an actual code right now, like on a real big system, and you need to get 10 times faster. What do you want to do? Do you want to just change the code and get 10x faster, or do you need to allocate 10 more times resources to get more machines or more cloud time or whatever? That's basically where the thing is, and that's something that people don't actually take advantage of. Because the current state of I need to write a SIMD complex code is abysmal actually. So you have this 1 order of magnitude of performance that just go to the drain because nobody wants to do the effort to use it.
You have to, your code has to be structured properly, right?
Yeah,
so you have to already get to the point where the problem is the loop, right? Or if you got to the point where your problem is a loop and you have your parallel arrays and now you want to get faster, right? Something like that, I think also Unity project have been doing. I saw at least a talk where they said that we're going to have where you can say, instead of a vector, you can say an SOA, of that vector. And they're going to use like SSE4, which is one of the extensions to vectorize your code, at least the basic stuff, but that's already really good. We also have an SOA vector, and we also we try to get you the same experience on the C++ library. Jason asked about, I can take that into my project. A couple of caveats, so just out of the box, like you need to compile a C++20, right? That's the library requirement. The regular thing about CMD applies, so it's processor extensions. You need to compile for a specific architecture, right? So if you, or at least a specific architecture, right? You need to understand, oh, okay, I'm targeting, let's say, processors from 10 years ago, and like this is the minimum requirement I have.
Right.
Or you need to do the horrible, very difficult thing and do the dynamic linking, which is what your libc will do, right? So a libc will have your implementation of your libc on your local machine, and it will use that one. So if you call, correct me if I'm wrong, Joel, because I might be wrong, but it will pick up the, the strlen implemented on your machine with a specific architecture. Yeah.
So if you say compile for SSE3, then you're not going to get any kind of runtime behavior. You're going to get SSE3 no matter where you ship that binary to.
Yes.
Fine.
Yes. There is. So sometimes people just built in the dynamic switch. For example, Microsoft STL implementation nowadays provides you with some vectorized algorithms out of the box. Okay. If you hit the specific type, like a reverse will be vectorized. And they do it, they have a dynamic sort of switch. So basically they detect what's your runtime architecture and they will select the correct implementation of reverse. It's a really cool piece of work, but it only works for like specific type if you hit it, and we can do all the other cool stuff.
Right. And what platforms are supported right now?
Currently most x86. Up to Skylake,
Visual Studio, GCC, Clang.
GCC Clang, no problem.
Okay.
Visual Studio is, how to say that, in the work. I'm still fighting against the fact that I'm sure I'm writing C++20 that Visual Studio should understand, but it probably doesn't understand it anyway. I did some trials on the Clang-based Visual Studio things.
Yes.
And it was okay. I mean, it compiled. I didn't have time to do any actual code gen investigation, but it compiled most of what we wanted him to compile. I mean, the thing that does not compile on Visual Studio is basically two things. Stuff that should be in the standard library, but apparently are still not there for whatever reasons. But usually it's easy to, it's easy to fix. That's the easy thing to fix. The other easy thing to fix is that you wrote proper C++20, but he doesn't want to compile it because, I don't know, like he's confused or something. One thing that come up a lot of time is when you do, you do fold expression in a context where the syntax is a bit complicated, like you want to do plus ... in a parent with one variadic types divided by another one, which is actually another stuff inside another template. You say, okay, I don't understand. And that are actually also easy to fix. It's a bit ugly with air quotes because you need to, slice the thing so you understand every bit and then you do the thing. But that's okay. And then there is a bunch of stuff it just doesn't want to compile, and I have no clue why, because when I do something similar, like in Compiler Explorer, it compiles. So it's probably a problem of context, like, I don't know, something is not parsed properly. But it's basically this. We are basically fighting, like the parser or something. So that's a bit of, like not very glorious works, but it has to be done. I really want to be able to get Visual Studio supported, because that's a massive segment of people that could be interested. And I know that, for example, from past experience with Boost.SIMD and with the old Eve, but more recently now, as Denis says, there is a lot of things that Visual Studio is able to to vectorize very well. for whatever it does. Okay, and I know that we have some bench that the success of the benchmark on Visual Studio will be we go just as fast because they just have this one perfect, like vectorize, I don't know, logarithm or whatnot, and it just happens to be called in a perfect loop and so on. So yeah, so Visual Studio is in the work. Clang GCC will require the latest version for now. The plan is that once they both support modules correctly, it will be our like baseline version, and we start actually modularizing the library, which is kind of done right now, but just at the physical level, we basically know where the stuff are going to be sliced, but it's not physically done. We also support ARM. Mostly the 64-bit parts. We probably support the 32-bit ARM-based 7 stuff, but I think that we have some glitches in the code that try to call the 64 bits when it should not. But that's something we have an issue on that. I think that's an active issue, I guess.
We have we are pretty close on ARM.
Yeah. It's probably like a dozen of things to fix. The thing is that for a very long time, you can right now go on the internet and you can fetch the what they call the Intel Intrinsic Guide, which is a massive web page where you type something and you have all the variant of the x86 intrinsics that do the thing with whatever architectures, whatnot. It's a very, very useful tool. And if I wanted to make a bad jokes, Eve is basically it's basically a C++ version of the intrinsic kit, because it was basically, we had the page open and we need to do that. What's the intrinsic already?
Yeah, I know.
Well, it has to be done. And
it's an odd set. Come on.
No, I said a bad joke, Dennis. No. But the basic things is, but as soon as we go up, it's better than that. And for a very long time, if you wanted to get documentation on the ARM CppCMD things, it was quite a challenge to find the proper version for the proper architectures you wanted to target. And for sometimes now, they basically have the equivalent of the Intel pages for ARM. And it's very, very easier now to find where we did things wrong, or finding intrinsic we didn't even knew existed before. So It's a bit of a whack-a-mole thing, because you need to fill all the hole you can find in the thing we should be supporting and we forgot about or we didn't know about, and so on. We have a very, very unsupported support, if I can say that, for PowerPC. It's in there because I had the code back from my PhD, and
you said PowerPC?
PowerPC, yes.
Okay.
They do. Yeah. This one thing that guy over there probably has in that. But the code was there since my PhD, so I just recycled it because, well, it doesn't change that much, if you see what I mean. I mean because Power 8 and Power 9 added a bunch of things. The main issue with IBM is that, contrary to ARM, which has a very good cross-compiler and a very good QEMU support, so we can actually, do emulation to test. PowerPC is you get that one version with that one version of GCC, and it's very complicated to get the other one. So It's more like we don't have the resources to do it than anything else, because all the system works the same anyway. So that's there because it's there. But our main, let's say that our main front end is x86 and ARM.
Okay. You mentioned the C++20 requirement, and I think, Joel, you mentioned big fan of if const expr. Denis, any other C++20 features you want to highlight that the library uses?
So I want to complain about concepts, if that's cool.
Sure.
It's massively helpful, right? So if const expr, you cannot write a library without if const expr. Whatever Joel says, it's a line. But with With concepts, there are a couple of things that people might need to learn. So, okay, first of all, perfect forwarding and concepts. If you know that perfect forwarding, when you do the deduction, you might get a tref as a type deduced, right? You might get a t, or you might get a tref. Like, let's say you pass a vector, your type might deduce as vector reference. And it means that the concept will be applying to that vector reference and not to the vector.
Right.
Which sometimes leads to very unpleasant situations where basically you're, I don't know what to do about it yet, right? But your concept might not work even that's what you meant. At the moment, I'm just removing references in all the concepts, which I'm not sure is a correct call. Maybe it should be remove reference in every invocation. The second thing to watch out for is that if the concept fails silently and you have a different overload, that is kind of like, for example, if you miss type name, right? Then the just concept fails and you get a different overload and you didn't even think about it. And in our case,
okay.
In our case, we have overloads that is like more powerful and then overloads that is less powerful, and we get a less powerful overload and it just works silently. Yeah, but also people say like, good error messages. Not from what I have seen, for most part for our code at least, because
Not yet.
No, there's a fundamental reason, right? When you have a template, you have a failure. That's one failure. When you have a concept, and let's say you had a restriction, you had an overload set. It was supposed to select overload number 3, right? It didn't. The concept check failed because something wasn't right. You get a failure for each of your overloads. And that can be quite deep. And so that is a bit painful, but still massively powerful tools that we use all over the place.
Concept if context expert. I think that the two things that I don't know what I was doing before, actually. Let's be honest.
100%.
But and we have this very fine stuff where basically what we do is that we use concept to discriminate on the architectures. So it's a very high level decimation of the overloads. And then when we know that it's that whatever, I mean, that's for x86 in this case. Okay, right. And then inside, we have those massive, like, I should actually call them like some kind of const expert switch, if you see what I mean. Those huge nest of if const experts that just go over every cases you can encounter for this version of the function. And they'll just say, just return that, or just return that. And the thing is that it's very helpful because what we had before, we actually add an overload for each of those if context for things. So if I just take apps, absolute value of x, that means that on x86 we had like something like 18 overload, something like that, when you factor in all the architectures. And how to say that? 5 overload, it's okay. 6 is okay. 18, it starts to be like just ridiculous, you see. And so now that we can just say, okay, this is this case, and you go there, and then inside, let's pick out which subversion you need. So you have less overloads, compile faster, because you just have to do like not this one, this one, and then inside you just pick up the correct if const expert and be done. It has its limitation because sometimes the if const expert net starts to look like a mess. Let's say this way, and then sometimes you want to like try to find the best how to say that angle to slice your if const expert so you have the minimum amount of them and the nesting is not too deep or whatever. And one thing we had to fight against with if const expert is sometimes you do if const expert something happens, okay, then if const expert something else happen, do this or do the fallback. Else, if something again different happens, do another thing. Else, do the fallback again. And the problem is that if you want to factor out the fallback, all the conditionals just look ugly, and you're stuck between like duplicating code or having stupidly complex conditionals, and so we have to navigate that. But most of the time it's okay, especially on ARM and the latest is 86, because it's just okay, we just have to basically make a mapping between the type, the size, and the actual name of the intrinsic, because nobody except PowerPC has a good idea to have intrinsic which does not contain the type and the size in the name of the function. Which is when you write generic code, it's like a huge mess, because you just have to enumerate all the cases. And even if you look at ARM, which is very fine, because you want to do a vectorize plus, it's probably v-add, and then something that looks like, the std int name, like v-add e8 or v-add u8, stuff like this. So you can actually find what you need, but you still have to do this 10 or 12, sub stuff that doesn't bring anything to the table except being this mapping. But yeah, it helps on that. It helps also in the algorithms, because we basically had to rebuild the basic concept for ranges and stuff. Tell me if I'm saying stupid stuff, Denis.
Okay.
But I guess it is. It was, it's the same thing, I guess. Algorithm without concepts, very complicated.
So it's like, this is a range, and this is, well, mostly it's a range. It's an iterator. We have a different notion of an iterator. That's things like that.
All right. Well, you're going to be doing a talk at CppCon, and obviously listeners should go and check that out. But it was great having you both on the show today, and everyone should definitely go check out Eve. Thanks, guys.
Yeah. Oh, so can you shout out Jean-Thierry?
I'm
I
sorry?
don't know how to pronounce it. Like, we have a third person who works on the library.
Oh yeah, of course, yeah.
Oh.
So I will be beaten with the rod. Yeah. So we. We are actually 3 people working on the library. Jean-Thierry Lapreste is also working with us. Is one of my past life thesis advisor, and we kept working together on that. And it's basically the guys that do the math. So we have a lot of math function in Eve. Some I know what they do, some I don't. And he wrote most of them. Is very good at numerical stuff. So half of the library won't exist if he wasn't there. So big shout out to Jean-Thierry for helping us on this part.
All right. Thanks, Joel. Thanks, Denis.
Thanks,
Thank you very much.